The number of molecules of carbon dioxide produced when 10.0 grams of calcium triacylcarbonate 4 is treated with 0.2 dm cube of 1 molar of hydrogen chloride in the equation is unknown. Solution. So the first thing to do in any question dealing with equation is to write out the equation as it is in the question given. So we'll be doing that. So let's see if it is a balanced chemical equation. Looking at this is a balanced chemical equation. Let's proceed. So we are asked to determine the number of molecules of carbon dioxide produced. To get that, we'll be using the formula that says that the number of entities equals moles multiplied by avogadros constant, which is 6.02 times 10 raised to the power 23 entities divided by 1 mole. The entities could be referred to as atoms, it could be molecules, it could be particles, it could be ions. Regardless of the entities, we'll have to be multiplying the number of moles of the substance in question by Avogadro's constant. So here now we are dealing with the number of molecules. So we'll just change entities here. We replace entities here with molecules. So we'll say number of molecules equals moles multiplied by 6.02 times 10 raised to the power 23 molecules divided by 1 mole. In this question, the substance we are asked to calculate its number of molecules is carbon dioxide. In the question above, we are not given the number of moles of carbon dioxide. We need to do that ourselves, and that's what will make our solution to be a bit longer, because we could have just substitute the values and go ahead calculating the number of molecules of carbon dioxide. So let's see, how do we get the number of moles of carbon dioxide in the question above? We can do that two ways. According to the question here, we are given the mass of calcium triacylcarbonate 4, and we are also given information for hydrogen chloride. So we can calculate the number of moles using calcium triacylcarbonate 4 or that of hydrogen chloride. But in this case, I would like us to check for the two if it will be giving us same value. Else, we'll be making use of the one that will act as the limiting reagent. So let's see. Let's start with calcium carbonate. So we have 10 grams in the question. To get the number of moles is always equals to mass over molar mass. So let's calculate the molar mass of calcium carbonate first. So without wasting much of our time, calcium is 40, carbon is 12, and oxygen 16. So calculating this, we have 100 grams per mole. So the mass of calcium carbonate is given to be 10, and it's moles of calcium carbonate equals 10 grams divided by 100 grams per mole, which is equal to 0.1 moles. Based on the equation above, if 1 mole, we have 1 and we have 1 as the coefficient. If 1 mole of calcium carbonate produce 1 mole of carbon dioxide, definitely 0.1 moles of calcium carbonate will produce 0.1 moles of carbon dioxide as well, or carbon dioxide, as well. So I'll just state here that moles of CO2 equals 0.1. So let's see if it is same value we'll be getting if we are making use of hydrogen chloride. In the question, we are given 0.2 dm cube of 1 molar of hydrogen chloride. So let's calculate the number of moles of hydrogen chloride in the question. Then we'll compare with the stoichiometric ratio, that is the volume in which they are combining here. And then I can say moles of hydrogen chloride equals the molar concentration, which is 1, multiplied by the volume in dm cube, which is 0.2. Multiplying this, we have 0.2 and the unit in moles. So based on the stoichiometric ratio in which they are combining, 2 moles of hydrogen chloride to yield 1 moles of carbon dioxide. So if we are now giving 0.2 moles of hydrogen chloride, how many moles of carbon dioxide will be produced? To get that, we'll just state that 2 moles of HCl will give us 1 mole of carbon dioxide. So 0.2 moles of HCl will give X moles of CO2. So cross multiplying indirectly, S equals 0.2 times 1 divided by 2, which is equal to 0.1, the unit moles. The moles of CO2 equals 0.1 moles. Either using calcium carbonate or hydrogen chloride as the limiting reactant, we are still having the same value of carbon dioxide that will be produced. So let's just proceed. Since we've gotten the number of moles of carbon dioxide produced, let's substitute it back into the formula written here. That is, number of molecules equals moles multiplied by 6.02 times 10 raised by 23 molecules divided by 1 mole. The number of molecules of CO2 equals 0.1 moles multiplied by 6.02 times 10 raised by 23 molecules divided by 1 mole. So this equals 6.02 times 10 raised by 22 and the unit molecules. This will be serving as the final answer. We've come to the end of the solution to the question, and we've gotten the number of molecules of carbon dioxide produced to be equal to 6.02 times 10 raised by 22 molecules. That will be all.